Find the shear stress at point C in pounds per square inch. In this problem, beam AB is a simply supported beam with a continuous load along the top of the beam. The beam has a constant rectangular cross-section with known dimensions, and point C is located 3 feet from point A and 2 inches from the top of the beam. The shear stress in a member, tau, in pounds per square inch caused by shear force equals the statical moment, Q, in inches to the third power, times the shear force, V, in pounds, divided by the area moment of inertia, I, in inches to the fourth power, and also divided by the beam width, B, in inches. From the cross-section, we can identify the beam width as 4 inches. But we still have to determine the statical moment at point C, the shear force at point C, and the area moment of inertia for the beam. We'll begin by solving for the shear force at point C in pounds. From the sketch, we can find the force at point C by creating a shear force diagram. To do this, we'll first sum the moments about point B, set the value equal to 0, and calculate the vertical force at point A, which equals 30 kips. Next, we'll sum the forces in the vertical direction and set the value equal to 0. The vertical reaction force at point B also equals 30 kips. Although the equation for shear stress shows the shear force term in pounds, we'll solve for the shear force at point C in kips and convert the units later. The shear diagram for beam AB decreases linearly from positive 30 kips just after point A to negative 30 kips just before point B, where the shear force at point C equals 15 kips. Having solved for the shear force, V, we'll next solve for the statical moment of the area, Q. The statical moment of the area is defined as a distance y times an area A, where the area A equals the cross-sectional area from point C to the end of the cross-section in the opposite direction as the neutral axis. The distance y equals the distance between the centroid of the area we just defined and the centroid of the entire cross-section. For the given point C, y equals 7 inches minus 4 inches, and the area equals 4 inches times 2 inches, which makes the statical moment equal to 24 inches cubed. Having solved for the statical moment of the area, the last variable we need to determine is the rectangular area moment of inertia, I. The area moment of inertia for a rectangular shaped cross-section equals the base width times the height cubed divided by 12. After plugging in the values for the base width and height, the area moment of inertia equals 171 inches to the fourth power. With the values for V, Q, I, and B calculated, these values are plugged into the equation for the shear stress and multiplied by a conversion constant of 1,000 pounds per kip. And the shear stress at point C equals 526 pounds per square inch. When reviewing the possible solutions, the answer is D.